All right, so compound inequalities can have two types of methods in which you can draw them. Okay, there is an and there is an or. Okay, now the and, if you see compound inequalities, I say the word and in between. By the way, compound means more than one. So not just one inequality like what we did yesterday, but they'll have you solve two of them at once. Okay? If there's a word and in between it, okay, I'm going to put right here, when you graph, the lines collide. They crash into each other. Okay, so whenever we're dealing with an and problem, the lines tend to collide. Now, sometimes they don't say the word and, but the symbols they use mean the word and. Now, what do I mean by that? If you see, let's say, an inequality that looks like this, this is an and, because the inequalities are pointing left. Okay? So because they're pointing left right here, this would be an and problem. All right? So if your inequality is pointing left, it can be less than or equal to. As long as it's less than, if they're pointing to the left, that means it's an and problem. So they could either literally say this and that, or it's going to be written like that, like all together in one piece, but the inequalities are pointing to the left side. Okay? Now the or, when you graph, the lines go in opposite directions. Okay? Now, usually you're going to see this or that, like this problem or that problem. Okay, you'll see that. This or that. But if they don't have it, then you may see something like this. This would be an or. And notice they're pointing to the right. Okay? So if they point left, we think and. Okay? Now it has to be like this big thing that's put together. Okay? That's when you look at those symbols. If they point left, it's an and. If they're pointing right, it's an or. Okay? So right now I'm going to kind of show you guys what these problems look like. We'll start off with some that are pretty obvious, where they say or and. Okay, and then we'll do like two where it's not so obvious. They're not going to literally say or and. They're just going to be symbols, and we get to figure it out. So here we go. Example number 1. We're going to solve and graph. You're going to notice when I do these problems, I tend to use a lot of colors when I do my graph, okay? So I tend to use a lot of colors when I do the graph. So here's one. This is going to be an or problem, okay? So x minus 3 less than 0, or 3x greater than 15. So notice this one literally says or on it. So it's not like, oh my gosh, I don't know what it is. Is it an and or an or? Like, no, you can totally tell that this is an or problem because it literally says or, okay? So it's not that big a deal. It's not like it's a mystery, all right? So that means that when I draw my graph, my answers should be pointing in opposite directions, okay? Not towards each other, but opposite directions. So that's what I'm looking for, all right? Now I have to solve each one of these individually. So let me do that. I'm going to add 3 to both sides for the first one. And I get x less than 3. And I'm done. That's done. Now let's solve the other one. I'm going to divide both sides by 3. And that gives me x greater than 5. And I'm done. So, all right, cool. I'm finished. Now remember, this is an OR problem, right? So I'm going to go ahead and draw, I'm going to draw my line here so I can graph this for us. Now, remember how yesterday, right in the middle, I put my answer? Remember that? If my answer was like x greater than 1, I put a 1 right in the middle, right? Now I got two answers. So I got to make sure both of those answers show up on my graph. So 3 and 5, I'm just going to make sure they fit. So I'm going to put 3 here. Here's 4. Here's 5. All right, cool. My answers are there. 6, 7, 2, 1. Okay, I got to make sure both of my answers are there. All right, now again, I tend to use different colors here, so we'll go with blue. X less than 3. So at 3, do I do an open or a solid circle? For x less than 3. Open or solid? It's open, right? Which way do I go, left or right? Left, because it says less than. All right, good. Next one, x greater than 5. Is that open or solid? Open at 5. And which way do I go? To the right. And I'm done. Here's my problem right here. Okay? Here's my solution based on the graph. And here are my solutions based on the work. Okay, so these are called compound inequalities. So 2 inequalities. It could be more, but usually 2 is all we do. And an OR problem, as you can see, the graphs are going in opposite directions. This or that, right? If it's an AND problem, you tend to see them approaching each other. So let me show you an AND problem. But before I do that, any questions on this one? So we're good? All right, so let's look at example 2. Solving graph. And here we go. 9x minus 2 less than or equal to negative 29. And negative 10x minus 6 is less than 44. So again, notice this one obviously says the word and, right? It's not being hidden in the work. It's there, okay? So what I have to do is start solving for my variables. So let me start with the left side. I'm going to add 2. When I add 2, I get 9x less than or equal to negative 27. And then my last job is to divide by 9. Okay, notice I'm dividing by a positive number. No need to flip the inequalities or anything like that. So x is less than or equal to negative 3. Notice doing the work isn't much harder than anything you did yesterday. So it's not like, oh my gosh, this is so much more difficult. But now it's just, we're doing a little bit extra now, right? We're doing 2 at once. So for the other one, let's add the 6. So I get negative 10. X is less than 50. Now when I divide both sides by negative 10, x, 50 divided by negative 10 is negative 5. But what do I do to that symbol? Yeah, I got to switch the side, right? Right now it's pointing left. It's going to have to point right because of the fact that they're dividing by a negative number on both sides. Okay? So, all right. And remember, this is an AND problem, okay? AND problem. So that means that when I graph this, the lines are going to go towards each other. And then once we draw them, then I'll show you what we do after. But let's go ahead and draw this out really quick. Give me a second here. Let me give myself some space because I always draw above. So, all right, so I need a -3 and a -5. So I'll start with -5, -4, -3, -2, -1, -6, -7. We'll kind of go up a little bit there. Now I got to do both answers, okay? So, x less than or equal to -3. Is that solid or empty circle? Solid at -3, a solid circle. Which direction? It's less than or equal to? You said? Left, right? Yeah, left. So here we go. Left. Okay. The next one. X greater than -5. Is that solid or empty? Empty, right? At -5. And which way does it go? It goes to the right. Now, if you leave your answer like this, it's not correct. Okay? Because what we're looking for is what they have in common. Because you see how it says the word and? They say it's this answer and that answer, whatever they have in common. Well, what they have in common is this part right here, right? Do you guys agree? This little section from here to here. So, my final solution looks like this. The red line is my correct answer. Okay, the blue and the green line kind of guide me. They tell me, well, this one's going this one, this one's going this way. Okay, and then once I get those two drawn, then I can say, okay, what do they have in common? Because it's an and. And then I look and I say, okay, then I'm just going to draw the piece that they have in common. Okay, so your answer isn't necessarily the green and the blue and the red. It's just the red line. But I always use the other colors as guides for me. Okay? And if you do this on your homework, I'll understand what you're doing because that's the way I process it too. Or if you're like, well, I like all that, but you know what? I'm just going to leave that as my solution. Right? I just want to erase everything else and I'm going to leave that as my answer. And that's okay. There's nothing wrong with that. Okay? Whatever you want to do. I mean, now I don't need to draw all three lines, but I know when I learned it the first time, I was doing all that stuff. Whoops, sorry about that. So, yeah, you don't have to draw all three lines if you don't want to. Okay? One student once told me, they said, what if I do it this way? You see how I have my answer on the top? They're like, could I draw my other lines like down here and then my answer up on top of the line? And I said, that's fine. Go ahead. Nothing wrong with that. Okay? Whatever makes it easier for you to do. So let me go ahead and just mark these off as correct answers here. So the first two that we did, they are obviously ands and ors. Okay? The next two, we won't make it so obvious. So example number 3. We're going to do 4 examples, by the way. You guys have 10 problems on your homework, so I'm doing 40% of your homework. So -11 less than x minus 5 less than -7. All right, now to do this problem, first off, you have to figure out, is this an and or an or? Because they don't actually tell me. But since they're both pointing to the left, what is it supposed to be? An and, right? If they're both pointing left, it's an and. Okay? So we're going to assume that this is an and problem. Now, I have to break this apart. Okay? I'm going to create one problem using this and another problem using this. Okay, I'm going to use the middle twice, but I'll use the left side and the left side inequality with the middle. And then I'll use the right side and the right side inequality with the middle. So I'm going to write two different problems. Negative 11 less than x plus 5 and, sorry, not x plus 5, I'm sorry, x minus 5. And x minus 5 less than negative 7. Okay? So I have those two things with the and problem. Okay. Now, what we're going to do next is go ahead and solve them. So let me give you guys a little bit of time. Go ahead and solve these two things. Okay, I'm going to pause the video. All right, so hopefully you have your solutions. Let's check them really quick. If you add 5 to both sides, you get x here, less than symbol, and negative 11 plus 5 is negative 6. So that should have been one answer you got. If we add 5 on the other side, we get x less than negative 7 plus 5 is negative 2. Okay? This is an and problem. Now what you might notice, if you notice negative 6 less than x, remember I told you some people don't like to see it, so if you want to flip it around, you could write x negative 6, and notice it's supposed to be pointing at the negative 6, so there you go. Here's another way to write that solution. Just kind of flip it around so it makes a little bit more sense for you, if that helps. Okay? So here's one of my answers. Here's the other one of my answers. Now let's go ahead and draw a number line. This is an and, right? So here we go. I need to fit a negative 2 and a negative 6 in my number line. So I'll start with my negative 6 here, negative 5, negative 4, negative 3, negative 2, negative 1, negative 7 over here. So so that fits all those numbers I need. By the way, you don't have to go by ones. You could have gone by twos, negative 6, negative 4, negative 2, 0, 2, 4, 6, right? You can do however you'd like. They'll give you graphs here, so you don't have to worry about that. So the first answer says x is greater than negative 6. Okay, x is greater than negative 6. So I'm going to go to negative 6, open or solid for that one. Open, all right. Which direction? To the right. Okay. The next one says x is less than negative 2. So I'm going to go to negative 2. Less than, open or solid? Open. And it's going to go left because it says less than, right? So less than is left. Since this is an and problem, I have to look for common ground, right? What do they have in common? That's what they have in common. Okay? So, let me draw my answer. And there it is. That's my and problem. Okay, they crashed into each other, and I got to show where that happened. So we'll do one more just so we can get 4 of your homework problems out of the way, then I'll give you guys your homework problems. Any questions on this one? Remember, for right there, your answer was this, okay? Well, it still is. Your answer is that. But a lot of people have a hard time graphing -6 less than x. Like they don't really understand it. So an easier way is just to flip it around, right? Rewrite it. X greater than -6 makes a lot more sense to people. I remember when I was learning this stuff in high school, the top one used to confuse me. And when my teacher says, well, just rewrite it. And then it all just started making sense. Like, oh, okay. Because for some reason, seeing the variable first just makes it easier to see. So, I would recommend you flip it around if you need to. All right, last one. So solving graph. And we're going to do one here that's compound 9 greater than or equal to 6n plus 9 greater than -27. Now the way this is written, what is this, an and or an or? It's pointing to the right. So what is it when it points right? It's an or, right? Points left, it'll be and. Points right, it's going to be or. All right, so this is an or problem. Remember, we're going to create our problems based on this and that. Okay? That's how we're going to create those problems. So here we go. 9 greater than or equal to 6n plus 9, or 6n plus 9 greater than -27. So let's go and start working on the left side. If I subtract both sides by 9, I get 0 greater than or equal to 6n. And then I just got to divide by 6. And I get n. I get a greater than or equal to there, and I get a 0 here. So 0 greater than or equal to n. If you don't like the way that looks, just flip it around, right? So we can just flip it around. That's n, a 0. And since the inequality is pointing at the n, bless you, let me make sure it continues to point at the n. All right, so there you go. Here's the first answer. Now for the other one, I'll subtract 9. That is way off. We get out at 22, so unless we have a new bell schedule that we have no idea for. So -36. I'm like, there's no way I talked for 52 minutes with 4 problems. So now I'll divide by 6. So n is greater than negative.
That bell was not dismissal. Thank you. Please disregard the bell.
That was more of an interruption than the actual interruption. So here we go. Here's your last one. Okay? Now remember, this is considered an OR problem. Okay? This is considered an OR problem. So, what do you do with that? Well, let's see. Oops, sorry about that. I pressed the wrong thing. All right, so we need 0 and -6. I'm going to go by 2's, okay? So here's, I'll put 0 here, -2, -4, -6, -8, 2, and 4. So every once in a while, an OR problem, you know how I told you they're supposed to go in opposite directions? About 98% of the time, they always go in opposite directions. But there's a situation, 2% of the time, when they actually go towards each other. So what do we do when OR problems go towards each other? So check this out. The first one, n less than or equal to 0. So at 0, I'm going to make a solid line, or solid dot, sorry, and I'm going to go left. Okay, then n greater than negative 6, open dot, and I gotta go right. Now, if this was an AND problem, if it was AND, it would look like this. And that would be your answer, okay? But that's not what this is. It's not an AND problem, it's an OR. OR problems, if they cross each other, what they basically say is, it doesn't matter whether they both share the answers, just draw me the answers they crossed over. So, here's your solution. Everything. Because notice, it crossed over negative 8, negative 6, negative 4, negative 2, right? It all crossed over. They crossed over 0, 2, and 4. They crossed over everything. And you might say, well, wait a minute. This one did not cross over right here, the negative 6. Very true. But the blue one did, right? The blue one crossed negative 6. Maybe the green one did not, but the blue one did. So as long as one of them crossed the answers, you got to include it. Okay? So you'll notice the lines crossed everything. So then your answer is everything. Okay? So that happens sometimes with OR problems where it becomes the whole graph. Okay? So that would be your answer.